everyone graphing linear equations. Okay, what is a linear equation? Do you remember from last year, Marco?
So a linear equation is like an equation that's linear, like if you add. Let me finish, please. Like if you add something to one of the variables, it'll go up in a steady path. It doesn't move.
It goes up in a steady path. It makes a line. What does that? It makes a line. So the word linear means a line. So the line could be up like that. The line could look like this. The line could look like that. But notice there's no curves. So a linear equation is a straight line. Okay? Yeah, so this is our x-axis, right? And our y-axis. And so we're getting into graphing now, right? Standard form of a linear equation is in the form ax plus by equals c, and a and b must be whole numbers. And we'll go over what that means in just a second. So ax plus by and c. So the x's and the y's always stay the same. But the a, b, and c, those are numbers that can change. But your x will always be an x, and your y will always be a y. Okay. Determine whether 5x plus 3y equals 5 is a linear equation. Well, what did we just say that the form of a linear equation would be? Grace?
A and B have to be whole numbers.
Okay. A and B, if they're in standard form, A and B have to be whole numbers. Is this in the form ax plus by equals c?
Yes.
Yeah. So is this a linear equation? Yes. This would make a linear equation, and guess what? It's already in standard form because A and B are whole numbers.
What would not be standard form?
So an example of not standard form: 1/2 x plus y equals 2. Is this a whole number? No. How would we get rid of this to make it a whole number? Times what by 2?
2 over 1.
Times everything by 2. And what happens to this fraction? Yeah, so this becomes 1x plus 2y equals 4. Is that now in standard form? Yeah, you just got rid of that fraction. You might want to write that down as an example. Yeah, that'd be a good example to write down. This is a linear equation because it's going to make a straight line. So something that wouldn't be a linear equation: x squared plus y equals 4. See how that's squared? That would not make a line. It would make something called a parabola. Well, this would make something called a parabola that looks like that. Is that a line? No. So if we had 1 over x plus y equals 12, is that going to be a linear equation? No. What about if we had x times y equals 12? Is that going to be a linear equation? No. Okay? So linear equation is going to make a straight line. So let's do some practice. Yeah, I'm listening.
Can you make that one, like the one that's x squared, can you even turn that into a linear or no?
Nope, this would never be a linear equation.
But the one below it could be.
Nope, none of these would be linear equations.
Oh, I thought it was 1 over 2, not 1 over x.
1 over x, because it's the x is on the bottom, so we couldn't do it. Yeah.
I have a question. So if you have like an equation and you're given one of the variables,
Uh-huh.
and that variable is in that equation, you put in it.
You plug it in.
Or could it be
Yep.
a different one?
You're going to plug it in, and we'll get there. Okay, so determine whether each equation is a linear equation, and if it is, write the equation in standard form. 6x minus xy equals 4. Linear equation? No. So can we put it in standard form? No. Okay. Why is this not a linear equation? What part of it? Yeah. See how it's xy right here? That tells me that this is not a linear equation.
What about subtracting? Can you do that?
So if it was 6x minus y equals 4, is that a linear equation? Yes. Is it in standard form? Yes. Because b is allowed to be negative. It just has to be a whole number. Okay. Determine whether 3 over 4x equals y plus 8 is a linear equation, and then write the equation in standard form.
We just do this on the whiteboard.
Sure, if you want to do it on the whiteboard, you can. Do we think it's a linear equation?
No.
Why not?
Because it equals to
Well, can we rearrange it?
Yeah. But it's not a whole number.
Okay, but can we make it a whole
I
number?
feel like it is a
It is a linear equation, but sometimes we have to mess around with it first. So remember the form is ax plus by equals c. So I need to get the y over here so I can minus y from both sides. So we get 3/4 x minus y equals 8. And then what am I going to have to do to get this into standard form? Times everything by 4. Nope, just times everything by 4 to get rid of that bottom number. 1 sec, Marco. Times 4, times 4, times 4. So we end up with 3x minus 4y equals 32.
Do you have to do times 4 divided by 3 or just?
Nope, just times 4 because are we allowed to have a number in front of x? Yeah. It's a whole number now. We got rid of that fraction. Let's practice. All right, you try, guys. You try. Okay, so
So wrong.
we need to know. We need to know the formula for standard form. So my recommendation to you is put that somewhere. It needs to be in the form ax plus by equals c. Can everyone remind me what a, b, and c are?
Numbers.
They're just numbers. They're whole numbers that we need to make. So right now, is it in that form? No. What do I have to do? I have to move this x to the other side of the equation. How do I move this x to the other side of the equation? Minus 4x. Minus 4x. So is the x or the y going to go in front?
X.
The x. So we have minus 4x plus y equals negative. Is it a positive y?
Yeah.
Okay.
No, wait,
But is negative 4 a whole number?
no.
It's an integer. It's a negative number. So how do we get this to become a positive? A has to be positive. Divide everything by a negative. So this becomes 4x minus y equals 5. Now it's in standard form, and it is a linear equation. I don't know how you would have.
Like, what if you did plus 5 to each side and then minus y?
You could have done that. Yeah. You could have done that, but it needs to be in this form, right? ax plus by equals c, or c equals ax plus by. But you'll mainly see it like that, where it's ax plus by equals c. So notice, all we had to do was move that x over and then divide by a negative. And that's why we had to do all that stuff in chapter 2, with solving equations, moving stuff around. All right, try this one. All right. So, this is not a linear equation. Why not? Sure, you're done. Okay? Can't have the multiplication like that. So that would not be a linear equation. What is an x-intercept? Does anyone remember that? Marco?
It's where the line intercepts the x.
So, in a coordinate plane, this is our x-axis, and this is our y-axis. An x-intercept is where we cross the x-axis. Where we cross the x-axis. So that would be the point x, comma, 0. So when we're finding x-intercepts, what does y equal? 0. So when we're finding, enough guys, when we're finding x-intercepts, it's where we cross the x-axis, and where we're going to cross the x-axis, no matter where it is, what's y equal to? 0.
Wait, so x-intercept is when you cross the
X-intercept is when you cross the x-axis. And then what about the y-intercept?
when you cross the y.
Yeah, so it's going to be the opposite. So we've got our y-axis and our x-axis. So our y-intercept is going to be where we cross the y. And what's x going to be in this case? 0. So that would be 0, comma, y. And maybe for these two examples, if we actually put dots on this, the x-intercept would have been 3, comma, 0 here, and the y-intercept would have been 0, comma, 3. Okay, so find the x and y intercepts of this graph. So if we're looking at this, what is our x-intercept? We look at the graph, we look at the x. Where are we intercepting?
4.
Good. So the x-intercept is at 4. And we would write that point 4, comma, 0. And then where are we intercepting the y? 200. So that would be the point 0, comma, 200. So, no. So the x-intercept, guys, the x-intercept is 4, and the y-intercept is 200. We would have gotten B. Grace said if you put them together, that'd be 4, comma, 200. No, that would be this point right here. That's not on the graph at all. An x-intercept is different than a y-intercept. We don't put them together. They're not friends.
So you just connect them to make them one.
Exactly, and that's what we're going to practice. All right, try this one. Awesome. X-intercept is 10. Y-intercept is 250. Okay, so let's look at this. A box of peanuts is poured into a bag at the rate of 4 ounces per second. The table shows the function relating to the weight of the peanuts in the box and the time in seconds the peanuts have been pouring out of the box. Determine the x and y intercepts of the graph. Well, we have a table up there. So we're going to be looking for zeros, right? Because zeros tell us intercepts. So at time x is 0, y is 200. So this is going to be an important point. 2000. What is 0, 2000? The y. Because we go over 0 and we go up 2000. So this would be your y-intercept. And then we look for our other 0 right here. We have 500, 0. That would be our x-intercept. So look for zeros. Zeros and intercepts go together. What do they mean? What does 0, 2000 mean? What do you think, Rachel?
It's like, it's where on the graph, it's where like the time and weight meet, but it's for the y-axis.
Mm-hmm.
The like the yeah is the like second point, so that's where you look to find. I don't know. It makes sense in my head.
So this is the intercept. But what does that actually mean? The time is 0. The weight is 2000. What does that mean?
So when you're at 0 time, you have 2,000
Ounces of peanuts. Because you haven't poured any out, right? So at 0 time, there are still 2,000 ounces of peanuts in your bag. And then after 500 seconds, there are 0 because you've poured them all out.
Oh,
Okay? So you've started at 0 seconds. You still have, let's just say it's 2,000 peanuts. And then after 500 seconds, you have 0 peanuts.
Yeah.
All right, try this one. So Jules has a gas card for a local gas station. The table shows the function relating the amount of money and the number of times he has stopped to purchase gas. So determine your x and your y intercepts.
Answer. Let's press it quick. She press it quickly.
Okay, so you've got to know how to graph points. So if we think about this as a graph, 0, 125 would be right here. 0, 125. That's your what? Y. So your y-intercept is going to be 125. So that one's gone, and that one's gone, and that one's gone. But how do we know that this is our x-intercept is 5? Because we had the point 5, 0. That's going to be your x-intercept. So plot it out. Draw it out if you need to, but you need to know how to plot your points.
Yes.
Yeah, Ingrid.
Do you always combine the bottom one?
No, it might not always be in the order.
But whenever there's a 0,
Yes, the 0. Exactly. Because the y-intercept, x is 0, and the x-intercept, y is 0.
Okay.
Describe what the y-intercept of 125 means in the previous problem. So let's go back. Okay? The y-intercept we said was 125. So remembering that Jules has a gas card, and it's talking about how much money you have and how many stops you've done. What does the 125 mean in the previous problem? So at time 0, there was $125. So if we look at this, if we come back to this graph, we're looking right here, right? So at time 0, how much money was on the card? 125. At stop 2, how much was on the card? How many times did it take him to stop before he had no money left? 5 times. Okay, that's how we read that.
Wait, so what was
The answer was C. Okay. The reason we're talking about intercepts is so that we can actually graph these equations. This is an example you should write down. So please take a moment to write down this example and draw out a quick graph. So we're looking at the equation 4x minus y equals 4. We want to find the x-intercept and the y-intercept. How do we find the x-intercept? Nope. Starting in standard form, which we like. So the x-intercept, we need to figure out what it is.
You solve for it.
How?
Well, you're gonna.
What do we know about the x-intercept?
It goes this way. That way.
Okay.
It goes to 6. It's horizontal.
Okay. We talked about this and what it means to be an x-intercept.
Oh, it intercepts the y.
It intercepts the x-axis. And what do we know y equals when we're intercepting the x-axis? 0. So to find the x-intercept, what does y equal? 0, because we're not going up or down anyway. We're crossing the x, and all here, where we would cross, your y equals 0. So to find the x-intercept, you set y equal to 0. So when you do that, 4x minus 0 equals 4. Well, this just goes away. Divide by 4. So x must equal 1. So we're going to cross the x-intercept at 1.
Wow. Yeah.
Nope, wouldn't cross at 4. And this is why we plugged in 0. So to find the x-intercept, y equals 0. And to find the y-intercept, x equals 0. So we go back to this original equation, and if we set x equal to 0, well, what's 4 times 0? So you just get negative y equals 4, so y must equal negative 4. So you're crossing y at 1, 2, 3, negative 4, and your line would connect those two together, and that would be your linear equation. Okay. So now you're going to decide if this graph is correct. So you need to find the x-intercept and find the y-intercept and decide if this is correct. So, it was yes. So, if the x-intercept, what does y equal when we find the x-intercept?
Y equals 0.
So if we take that away, because when y equals 0, that goes away. So 2x equals 10, so x would equal 5. Do we cross 5 on the x? Yeah. So the other one, 2x plus 5y equals 10. When we're finding the y-intercept, x equals 0, we can cross that out. 5y equals 10 divided by 5. Y equals 2. Does y equal 2? Yes, so it was yes. Colin. All right, quickly. We need to graph by making a table. Y equals 2x plus 2. When you're graphing by making a table, you have your input, your domain, your x, your output, your range, your y. What's one number you want to put in?
0.
Let's put in 0. If we plug in 0 for x,
This is the one I was
if
talking
we plug in 0 for x, what are we left with?
Yeah.
2. So that would be the point 0, comma 2. What's another point we could plug in?
4.
Okay, plug in 4. If we plug in 4 for x, what's 4 times 2?
8.
Plus 2 is 10. So that's actually going to be off.
Oh.
Okay, so maybe we should plug in like negative 2 or 2. If we plug in 2, 2 times 2 is
4.
plus 2 is, so that would be 2 comma 6.
Plug in 1.
Plug in, well, where do you have a lot over here? Maybe like negative 3. If you plug in negative 3, 2 times negative 3 is
Negative 6.
negative 6 plus 2 is.
Negative 4.
So this would be by making it, by doing a table. And then at the very end, what do you have to do? Make your line, connect your graph. You're just plugging anything in. I always recommend plugging things in like this area, which means from like negative 3 to 3 maybe. 0 is always an easy one to plug in, okay? We're not going to have time to do this right now, but that was it.
Wow.